Alright, so sorry, I'm having to make this video on my phone, cause, one second. Yeah, one sec. Cause I left my laptop at school, which y'all can probably see because it's on my desk, so I can't do presentation mode, so hopefully this is good enough, but the lesson today is lesson 3.1. You can find these on the calendar, and you can look at these slides for yourself. But basically, we're finally going to get to do some real math. So I'm not going to be there today or tomorrow. So today and tomorrow, just try your best on the lesson check and the homework assignment. 3.1, send me messages on Remind or email me if you have questions. It's set for 2 attempts, but if you need more, I can unlock them. So don't feel too stressed or pressured because I wasn't supposed to be out, but my little guy's sick, so I gotta stay home with him. So lesson 3.1, the first slide is talking about normal distributions. So this only works in normal distributions, okay? I know we talk about skewed distributions a lot too, but this math we're about to apply only works in normal distributions. I don't know what this random dot is on the curve right there, but just ignore it. A normal distribution is unimodal or bell-shaped, and as we talked about it on the test yesterday, in a normal distribution, the center is mean and the spread is standard deviation. So we're going to talk about something called a z-score, and this is really the first true statistical thing that we're going to talk about. But so z-score is a location. A z-score is how many standard deviations a particular data point is away from the mean. In that distribution that you can see at the top of the screen, the mean is the dead center, right? The mean is in the middle. Standard deviation is how far away from the middle a particular point is. So like a positive standard deviation means you're above the standard deviation. Oh, did you pick the chair up? Good job. A negative standard deviation means you're below the mean, okay? But think of z-score as a location and how far away you are from the mean, okay? There's 3 formulas. The middle one is the normal formula. It's just 3 different ways to say the same thing. But focus on the middle one that I drew an arrow to. Okay, example number 1. Let's say that I want to find the z-score of a price of Jordans that cost $247 if the mean price is $279 and the standard deviation is 16. So basically, I go to the store, I see that the shoes cost $247, and I want to know how good of a deal this really is. Okay? So, the formula right here, hopefully this zooms in on my screen recording, but is z equals x minus x bar, which is the mean, divided by s, which is standard deviation. Okay? I tell you that the mean is 279, so we're going to replace x bar with 279. I tell you that the cost of my shoes is $247, so x is the data point. And I tell you the standard deviation of the data is $16, so that goes on the denominator. Okay, so x is the data point, x with the line over the top is the mean, and s is standard deviation. So we do the math, and the math tells me that we have a z-score of -2, which means in English, this pair of shoes at this store is 2 standard deviations below the mean. And I know it's below because it's negative. And by below, I mean left than on the graph, left of the mean on the graph. Okay, hope that makes some sense. I'm trying to go quick, but what is the z-score? Example 2, what is the z-score of a data value of 23 if the mean is 16 and the standard deviation is 3? Okay, so again, I give you the data value of 23, which is x. I give you the mean, which is 16. And I give you the standard deviation, which is 3. We plug all that into the formula, and we get a z-score of 2.33. And again, this means that the data value of 23 is 2.33 standard deviations above the mean in this case because the z-score itself is positive. Okay. Last one is example 3. Okay, I guess it won't let me scroll down, so it's just going to stay at the bottom, but is example 3. So given a distribution with a mean of 60, a standard deviation of 21, find a data value if the z-score is 2.19. So basically this last one's just playing with the formula, right? I tell you that the z-score is 2.19, so we replace z with 2.19. I tell you the standard deviation is 21, so we put a 21 for s. I tell you the mean is 60, so we put a 60 for x bar. And then now we go back to algebra 1, and we're trying to get x by itself. So we multiply both sides by 21. And when we do that, we get 45.99 equals x minus 60. And then we add 60 to both sides, which gives me an x value or a data point value of 105.99. Okay, so in lesson 3.1, we're talking about z-score. In lesson 3.2, we're going to talk about how to turn a z-score into a percentage or a percentile. So if you've ever taken the SAT or ACT and you log on to your College Board account and it's like you got a 1300, which is you are in the 54th percentile or whatever. This is exactly how they find it, okay? They find your z-score, and then there's an extra process after this, but that's lesson 2. So for this lesson, we just need to know that z-score is a location, and it's the location of a particular data point and how many standard deviations away from the mean a particular point is. A positive z-score means that your particular data point is above the mean. A negative z-score means your particular data point is below the mean. Okay, I know that was quick, but hopefully it helps.